Now we will see about the example of recursive definition, that in exam how it can be asked. Suppose f of n is given as 2 power n, where n is a natural number. Now they can ask like give recursive definition of the function. So first step is we have to check for the initial condition. That means we have to check for the f of 0. If we put n is equal to 0 in the given function 2 power 0, we will get 1 because any number with the power 0 is 1. Now we will go with second step, that is recursion. We will write function first f of n is equal to 2 power n. F of n is equal to 2 power n. First f of 0 is equal to 2 power 0, 1. F of 1 is equal to 2 power 1, 2. F of 2 is equal to 2 power 2, 4. Here what we can write 2 into 1, 2 into 2. F of 3, 2 power 3, that is 8, 2 power 4. Here you can observe that each power is 2 times the previous power. That means this is previous term 1. This is previous term. This is previous term. What is common in all this? This is previous term and multiplication of the previous term is always 2. So here the repetition is occurring. So mathematically what we can write, f of n is equal to, if we take these numbers as n, that means 2 power n is equal to 2 multiplied by previous term. That means this is f of n minus 1. So we can write 2 into 2 power n minus 1, right? This is what we can write like this. 2 power n is equal to 2 into 2 power n minus 1. If we will write in the form of function, f of n, 2 power n is f of n, 2 into f of n minus 1. Because if we put n is equal to n minus 1 here, we can write it as f of n minus 1 is equal to 2 power n minus 1. So this is our recursive definition of the given example. Now we will see another example which we already know. Give recursive definition of f of n is equal to n factorial. Now what is our first step? First step is check for the f of 0. If n factorial is given, f of n is equal to n factorial, then 0 factorial. 0 factorial means 1. Second step is find recursion. That means check for each value. F of n is equal to n factorial. F of 0 is equal to 0 factorial, that is 1. F of 1 is equal to 1 factorial, that means also 1. F of 2 is equal to 2 factorial, that is 2 into 1, that means 2. F of 3 is equal to 3 factorial, that means 3 into 2 factorial. 2 factorial is 2, means 3 into 2 is 3. Now, f of 0 is 1, f of 1 is 1, f of 2 is 2. But we will see here. We can write f of 1 as 1 into 0 factorial. F of 2 is 2 into 1 factorial. F of 3 equal to 3 into 2 factorial. Now observe the pattern. F of 2 is the 2 with the previous factorial. This is, we can write like this also. 2 into previous factorial. Here 3 factorial is 3 into previous factorial. Here, if we want to write 4 factorial, 4 into previous factorial, that means 3 factorial. 4 into 3 into 2 into 1, like this. So what we can say? We can say that f of n can be n into previous number factorial, n minus 1 factorial. And what is f of n here? N factorial. That means n factorial is equal to n into n minus 1 factorial. This is our recursive definition of f of n factorial. So we can write like this: f of n is equal to n into f of n minus 1, where n is greater than or equal to 1. Now we will see about structure induction. Firstly, we have seen mathematical induction. In mathematical induction, numbers are built from 1 to 3, 4. That means if we want to go to the 4, we have to first visit 1, 2, 3. And for structure induction, structures are built from small piece, then go to the bigger piece, then even go to the bigger piece. That means you prove that it is true for basic building blocks. If true for smaller parts, then it is true for structure made from them. Right? Structure induction is like mathematical induction only. But instead of proving something about numbers, we prove something about structures. The structures can be expressions, trees, lists, string, recursively defined objects. That means other than numbers, all the things are structure. Here we will see one example about list. Suppose we can define a list like this. If we want to define empty list, we can write it like this. If L is a list and X is an element, suppose one element inside the list, suppose X or A, then we can write like this, that this element is inside the L. Suppose the element A is inside the list, we can write like this: A is inside the list. If X is inside the list, we can write it like this: X is inside the list. Now suppose we want to prove that length of a list is always greater than or equal to 0. Then how we can prove? As we have seen in mathematical induction, first step is the base case, in which we will check for the 0. So here also we will check for the length 0. We can write like this: empty list. That means length is 0 or greater than or equal to 0, we can write. Now the second step is inductive step. In this, we will assume that list is greater than or equal to 0. Then what can be the length? Length we can write like this: is equal to 1 plus length of list. What is the length of list? Here first is 0, which is 1, which is 1 is greater than or equal to 0. So it is true for the small part, that means 1 plus length. It is true for the all the list. This is what structure induction is. Now we will see about the languages. The topic languages will be very helpful in the whole subject POC. We will see some 3 to 4 concepts which are coming in the languages. First is alphabet, second is symbol, third is string, and fourth is language itself. First, what is alphabet? Alphabet is a finite collection of symbols. Then what is symbol? Symbol is the character. Character means any alphabet, letter or picture. For example, A, B, C, 0, 1 or any picture. That means symbol. And the symbol of the and the collection of the symbols is alphabet. Here we can write like this. If the collection of the symbol is any alphabet, any character, then we can write it like this: A, B, C, up to Z. If the collection of the symbol is any binary number, then we can write it like this: 0, 1. Now what is string? String is finite collection of symbols from alphabet. Here note that finite, that means it is countable. We cannot make the collection of infinite symbol. We have to make collection of finite symbol, finite alphabet. For example, we can write string as like this: sigma. For example, if sigma is equal to AB, that means it is a collection of symbols from alphabet A, B. Then, what can be the various strings we can form from this? We can form the various string like A, AB, A, ABB, like this. For alphabet AB with letter N, number of strings can be generated is 2 power n. That means if in the example it is given that generate the string of length 3 from the given finite collection of symbols, then how many numbers of strings can be generated? 2 power n, that means 2 power 3, that means 8. This is what this line is saying all about. Now, if there is any empty string, then how we can write it like this: epsilon. This is sigma and this is epsilon. Empty string can be denoted as like this: epsilon or epsilon, whatever you like to call. Let's take one example. Number of strings that can be generated over the alphabet A, B of length n. What we have seen here, 2 power n, that means 2 power 2, that means 4 strings can be generated from this given example. This can be string AA, AB, BA or BB. Here length of the string we can write like this. This is sigma, not epsilon. So here we have said that length of 2. So this is what we can write. And number of strings can be 2 power n, that means 2 power 2, 4. This is now the next concept is language. What is language? Language is the collection of strings. It is defined using an input set denoted by letter sigma. Here also we can denote language as sigma or L. Suppose language given as epsilon 0, 0, 0, 0, 0, 0. Here what we can write language as any number of zeros. We can write language L from the string like any number of zeros. In language, there are two types: finite language and infinite language. What is finite language? Finite means limited collection of strings, and infinite means unlimited collection of strings. Suppose L1 is given a set of string of 2. That means length should be only 2 for the given string x, y. Then how we can write language as L1 is equal to xy, ys, xs and y. In infinite language, if language is given like it is a set of all strings starts with B. That means any string which starts with B can be the collection of this language, can be the part of this language. So what we can write, L1 is equal to any string start with B. That means we can write like B, BB, B, 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 A, B, A, and up to infinite. So this is infinite language. Now there are some operations which we can perform on string. Mainly three operations: concatenation, transpose, and palindrome. First, what is concatenation? Concatenation means to join. Concatenation means join. Two strings are combined together to form a single string. Two strings are combined or joined together to form a single string. For example, if X is white and Y is house, then what can be the concatenated string from this? X into Y. That means white house. Now the second is transpose. Transpose is also called as reverse operation. For example, here XA transpose is given. Then what we can write? We have to reverse this AX in the transpose. We can also write like this one. Suppose this is the string given ABA, and we have to find transpose of it. Then we have to reverse. That means BBB, ABA. This is the transpose of the given string. One more example. If relation R is given as 1, 2, 2, 3 and 3, 4, what can be transposed? R to the power T. That means R transpose, or we can write it like as R minus 1. Then what is the transpose of relation? We have to reverse this. 1, 2 can be written as 2, 1, 2, 3 can be written as 3, 2, 3, 4 can be written as 4, right? Now last operation on string is palindrome. We already know that what is palindrome. Palindrome is the string which can be read same from the left to right as well as from right to left. For example, string madam. If we read from left to right, it is read as madam. If we read from right to left, it is read as madam. So this is palindrome. Now we can also perform some operations on language also. Suppose if L1 and L2 languages are given, then we can perform these operations on language: union, concatenation, intersection, and difference. What is union? Union of two languages denoted as L1 union L2. This is how it can be denoted as. Concatenation is denoted as like this: L1 into L2. Intersection of two languages is denoted as like this: L1 intersection L2. And the difference of two languages is denoted like this: L1 minus L2.